Hello guys, welcome to today's class where we're looking at another example under our Pascal triangle and how we can apply it. Now, in this question is slightly different from the previous ones. In this case, we have a question where we are told that what from Pascal's triangle, expand and simplify 2 plus p over 2 all raised to the power 4. Hence, using the expansion derived from the above stated, determine the value of 2.5 raised to the power 4. Now, we'll be using our expansion now to solve a particular mathematical expression. So before we can even solve that question, let us first use the idea of Pascal triangle to expand this binomial theorem. Now the question we have here is 2 plus p over 2 all raised to the power 4. We know from Pascal's triangle, from our table of coefficients, from our triangle of coefficients, we remember that for a power 4, the coefficients we use are what? Are 1, 4, 6, 4, 1. So those are the coefficients we'll be using. We have 1, 4, 6, 4, 1. So let us expand. We know this is the first value and this is the second value. So for the first value, we know the very first thing to do is to take the first value with all the power. That means we have our coefficient 1. Then we have 2 raised to the power 4. And then we have p all over 2 raised to the power 0. We move on. We have next coefficient, which is 4. We have 2 raised to the power 3, because the power of 2 reduces while the power of p over 2 increases by 1. So we have p over 2 now. From 0 it becomes 1. Go to the next one. That's the 6 coefficients. The power of 3 has reduced from 3 to 2, while the power of p over 2 has increased from 1 to 2. Moving on, the next one, coefficient 4. Now the power of 2 has reduced from 2 to 1, while the power of p over 2 has increased from 2 to 3. So as the power of the first one is reducing, the power of the second value is increasing. So the last one now, with the last coefficient, which is 1, we put our 1. Then we look at our 2 raised to the power 1. 2 raised to the power 1 reduces by 1 now. The power becomes 2 raised to the power 0. While our p over 2, which was raised to the power 3 before, is now raised to the power 4. So after that, we can now simplify and expand. Simplifying and expanding, we have 1 times 16. We know 2 raised to the power 4 is 16. Writing our 16 here, we have 16. We know p over 2 all raised to the power 0. We know that anything raised to the power 0 is 1. So this is basically 16 times 1 plus 4 into brackets. 2 raised to the power 3 is 8. And then p over 2 raised to the power 1 remains p over 2. So the next one, we have 6 into brackets. 2 raised to the power 2 as 4. And then p over 2 all square, where p square is, we have p square over 2 square is what? 4. Moving on, we have 4 into bracket. 2 raised to the power 1 is 2. And then p raised to the power 3 remains p raised to the power 3. And then 2 raised to the power 3 is 8. Moving on, I can now add here. 2 raised to the power 0 is 1. P raised to the power 4 remains p raised to the power 4. 3 raised to the power 4 is 16. From here now, I can now break it down. I have 16 times 1 is 16. Plus 4 times 8 here giving me 32. 32 divided by 2, I have 16p. Plus, I know my 4 here can cancel my 4 here. I have 6 times p square. I have 6p square. Plus, the next one here, I'll be having 8, cancel 8, I'll be left with what? P cube plus p raised to the power 4 over 16. So this will be my values of my coefficient. This will be my expansion. This will be the values I'll be getting after expanding 2 plus p over 2 all raised to the power 4. Now, that means I've satisfied the very first question that we're asked to find. But in the second question here, the second part of this question, we're told that hence, using the expansion derived from the above stated, we are asked to determine the value of 2.5 raised to the power 4. In order to determine the value of 2.5 raised to the power 4, we need to remember that we are comparing 2.5 raised to the power 4 to 2 plus p over 2 all raised to the power 4. So, by comparison, we are comparing the idea of 2 plus p over 2 all raised to the power 4 to 2.5 all raised to the power 4. And we know by comparison, we can actually equate their powers. Equating their powers, we have 2 plus p over 2 equals to 2.5. In order to, the next thing I do is to solve for my p. Solving for p, I'll have p over 2 equals to 2.5. 2.5 minus 2. Our p over 2 here equals to 0.5. And then upon multiplication, that is after cross multiplying, I can now say my p here will be 2 times 0.5. Therefore, my p gives me a value of 1. Now that I've been able to get a definite value for my p, all I need to do now is to substitute into the expansion that I derived above. So recall that p, recall that was that was 2 plus p over 2 all raised to the power 4. When we expanded it, it gave us a value of 16 plus 16p plus 6p squared plus p cubed plus p raised to the power 4 over 16. I think that's what we had there. So since we can recall this, all we need to do now is just substitute our value of p equals to 1. So we now say, therefore, for 2.5 raised to the power 4, and I say 2.5 all raised to the power 4 here, will just be a simple case. So for 2.5 raised to the power 4, we know that p is equals to 1. So in order to apply this, we just substitute a value of p for 1 from the original expansion. We have 16 plus 16 times 1 plus 6 times 1 squared plus 1 raised to the power 3 plus 1 raised to the power 4 all over 16. I'll be having my value to be 16 plus 16 plus 6 plus 1 plus 1 over 16, which will be giving me a total value of 16 plus 16 giving me 32, 32 plus 6, 38, 38 plus 1, 39, that will be 39 no number, 1 over 16. So this will be my value of 2.5 raised to the power 4. It can also be expressed in decimal as much as you like, but it is okay in this form. And then this is where we call it a day here. In the next class, so this is where we round it off on Pascal's triangle. In the next class, we'll be looking at another method we use in solving binomial expansion questions, such as the combination method. So we're looking at what the combination method is all about and how we actually apply it in solving binomial theorem questions. So see you next class. Have a nice day.